Okay, good. Everything is good. And here is the screen. Hope you all see the screen now. If you have any questions, please you can unmute. And when I give you a chance, you can unmute and ask me those questions, or uh, you can send me those questions into my chat box, but I will not be able to see it while I am presenting, but I'll try my best to catch up your questions. Right. Okay. Here, the thing I have to share that we may have more than one review session. The how and I want to go over these questions with you all that would be covered, that will be covered for in the unit exam 1 and as well as in the final exam. Right. The first question, these questions are based on the chapter 1, the from the essential ideas, the concept, the basic concepts. We talk about the significant figures, unit conversions and scientific notifications, and the doing some conversions, and with focusing on the significant figures. Right. The first question: determine the number of significant figures in each of the following values. When you look at this one, the 20, so we do not count the uh, the zeros in the after the number. If there is a decimal place, okay, then we'll count. But there is no decimal place. So in 20, we count only the number 20 as a significant figure. So it has only one significant figure. When you look at the next one, the 0.080, in that case, we do not count this 0, but in a decimal place, when there is a decimal value, we'll count the zeros after a figure. So here, these are the significant figures. So this number has two significant figures. Now we see a number with in a scientific notification. So we don't worry about the value as the given as a power of 10th. Yes, we don't worry about that. But we'll count the number of significant figures in that number. So again, this 0 is after the decimal place, like it is even followed by a number, so we count it. So in total, we have three significant figures. In the next number, the 0 is in the middle of two numbers. Okay, so then we should count that 0. So again, this value has three significant figures. And here it says 10 students. So it is, this is not a unit. So we cannot like, we don't give an exact number. So that's an infinite number of significant figures. Here, 550, a decimal place, right? If this one, 550, was just given like that, then we do not count that 0. Okay, if this is was given like any with a unit. So then we'll count this as two significant figures. But in this number, there is a decimal place there. So this number was recorded up to that the place. So this number has three significant figures. Right. Do you have any questions? I'm sorry, I don't hear you.
Not sure if you can hear me now. Can you hear me now?
Um, yeah, a little bit. Yeah, can you increase the volume a little bit?
Yeah. So is that better?
Let me see if I can increase the volume. Yeah, yeah, please go ahead now.
Okay. So for number, well, the one with the 10 students, you said that
Mm.
was infinite,
Yeah,
so we would never give a true value for that because I guess because so if it were like 12 students, we would just say the same answer choice. It's just infinite.
yeah, because it has a zero
Hmm.
at the end.
Okay.
That yeah, that is the reason. Yeah, I
Okay.
like 12. Like when you don't give get the value in with a unit, we don't know how much is it. So then we our answer when we giving a final answer, we don't depend on that number.
Okay.
I think I have included a question later on, like as an example, when we do a question like this, like 1.2 times like the inches in 10 boxes, like that. Okay, so this
Hmm.
10 has infinite number of significant figures. So then we don't depend on that number, but we'll give the final answer with two significant figures because our answer should depend on or should consider the number of significant figures given with that 1.2.
Okay. I understand. Thank you.
You're welcome. Okay, right. Let's go to the next question then. Convert. Now we are talking about the conversions. Convert 2.18 times 10 to the negative third grams to milligrams, kilograms, and picograms. Yes, you will ask me this question. Do we need to know the conversions? No, not for the first exam, not for the first unit exam. I'll try to give all these conversions just for the first unit exam. But beyond that, you will not be given these constants. You should know these the like the uh, what do you say, like the very common conversions. Like I don't give like, oh, 1 liter equals 1000 milliliters. No, I may not give those conversions for your final exam. But if you need any conversion for any question in the unit exam one, you will be provided all these conversions with the formula sheet or with the question itself. Right. So let's try to solve this. So we first try to convert the grams into milligrams. Right. So we'll start with the given value. Right. 2 point, right, 2 point, mm, let me, 2.18 times 10 to the negative third grams multiplying by, now we'll use the conversion factor. So we here the answer is given in grams. Therefore, you should get the grams into the denominator. And what you were trying to convert it into should be right in the numerator. So 1 gram, then we'll get that 1 grams equals to 1 times 10 to the third milligrams. So that will be easier for you to uh, convert this one. So then the final answer would be 2.18 milligrams. Right. And the next one, 2.18 10 to the negative third grams. Again, we'll get the 1 gram in the denominator, and then we'll get the relationship between the grams to kilograms. So 1 gram equal to the 1.10 to the negative third kilograms. Right. So then the answer will be 1 point, sorry, 2.18 times 10 to the negative 6. You will see here the grams to grams cancel out, and we'll get the answer in kilograms. Right. Next one, 2
I'm
point,
sorry.
yes,
Um, I'm sorry for the little conversion sheet. Is to go to kilograms going to be 10 to the positive 3
1
or not?
gram equals to the 1 time 10 to the negative third kilogram. Okay.
Okay.
Yeah. So the next one, 2.18 times 10 to the negative third grams equals, again we'll get the relationship between grams to the picogram. 1 gram equals to the 1 time 10 to the positive 12th. Okay, picograms. So again, grams to grams cancel out, and we'll get the answer in picograms. So the answer will be 2.18 times 10 to the ninth picograms. Right. So you'll get the conversion. Like always, write the one given with the what is given with the question in the denominator. Then it would be easier to arrange this dimensional analysis, and you will get the answer what the in the unit that was asked in. Right. You have any of you have questions? We'll go to the next one then. Now we'll converting 12.5 square feet to square centimeters. Right. Now okay, you'll understand, right? You have not seen a direct relationship. You are not given the direct relationship between the feet and the square centimeters, but we have a relationship between, we know the relationship between the feet and the inches, and also we know the relationship between inches and the centimeters. So this is combining two steps. So again, don't we will start with the value we were given. So it is 12.5 square feet times, right? We'll get the relationship. So we'll write 1 feet in the denominator. And what is the relationship between 1 foot to the inches? It equals 12 inches. Okay. And we will square this since the value was squared. Right. Then you will see the square feet to square feet were cancelled out. Right. Then we'll have the inches. The answer is in the units of inches. So what should be gone into to the denominator? Yes, it should go the inches. 1 inch equals to 2.54 centimeters. Right. Again, is that correct? No. We should the hmm, um square it, and then you will see the square inches to square inches were cancelled out, and we'll get the answer in the square centimeters. Right. So the answer will be 1.16 times 10 to the fourth square centimeters. Right. Any questions? Okay, if you don't have any questions, I'll go to the next conversion. Here we'll do conversions between the Kelvin and degrees of Celsius. What is the conversion factor? Yes, Kelvin temperatures equals to the temperature given in degrees of Celsius plus 273.15. Right. So now we need to convert the temperature given in Kelvin to degrees of Celsius. So then that the must be Kelvin temperature minus 273.15 equals to degrees of Celsius. Right. Okay. So we'll get the degrees of Celsius. So what is the answer given in Kelvin? It is 99 minus 273.5. So we will get a negative number. So that will be minus 174.15 degrees of Celsius. Any questions? Okay. Next, we are converting the Kelvin into the Fahrenheit temperature. Again, we don't know a direct relationship between Kelvin and Fahrenheit. We have to change the temperatures first into degrees of Celsius, then we can do the conversions back and forth. Right. So again, if I just use a different color to mention this, the conversions degrees of Celsius equals Kelvin temperature minus 273.15, and then we'll change the 455 Kelvin 455 Kelvin into degrees of Celsius by subtracting 273.15. That will be equal to 180 81.85 degrees of Celsius. And then now we'll consider this the Fahrenheit. The Fahrenheit, the conversion factor between Fahrenheit and degrees of Celsius, again that will be given uh, 9 divided by 5 times degrees of Celsius plus 32. Okay, now we'll plug the value that we got obtained for the degrees of Celsius. That will be 9 divided by 5 times 181.85 plus 32, and that will be equal to 359 Fahrenheit. Right. Questions? Yes, you will be given those the units and the conversions. The next question. Okay. At the end of the module 1, we talk about the density. What is density? The equation. The density equals the mass divided by the volume. Right. So, in abbreviations, M over V. Right. What is the density of a solution with the volume? Oh, we are given the volume and we are given the mass. So that's a very like a straightforward question. Right. But we should be very careful with the when we are operating these the calculations, and we should be very responsible in operating the units as well. Right. So D equals M over V, and the mass equals to the 25.2684 grams divided by 26.73 milliliters. Right. The answer, I'll just put whatever I seen here into the calculator, and this is the answer I got. 0.9453,199. Right. So, should I give that number? No. Now I should consider the number of significant figures. Right. Here, look at this one. The first one has how many significant figures? 1, 2, 3, 4, 5, 6. It has 6 significant figures. The denominator now value has only 1, 2, 3, 4 significant figures. So when you doing a multiplication or division, the final answer must be given with the least number of the significant figures. So this value has only 4 significant figures. Therefore, the value should be given with 4 significant figures, and it should be round. Okay, after 3 here, I have 1. That is less than 5. So am I going to add a 1 to 3? No, I will not. So the answer should be given as 0.9453 grams per milliliters. Here we got these units. Okay, right. Questions. Okay, the next one. Use the calculated density. What is the calculated density? The calculated density is 0.9453 grams per milliliters, right? So here, that is the calculated density. And we should determine the volume of exactly 1 gram of solution, right? So D equals M over V. Now we are looking for the volume. So we should rearrange this equation to solve for the volume. Then volume will be equal to the M over D. I hope it is clear for you all. Right. Now I plug the values for the mass and the density. What is the mass? Mass is 1 gram. Okay. 1 gram. And then I divide by the density. 0.9453,199 grams. Oh, I got that. grams per milliliters. Right. Again, this 1 gram, it doesn't say anything. It's just 1 gram. Okay, so it has infinite number of the significant figures. Therefore, we stay with this value. So the answer should be given with four significant figures. When I plug this one to the calculator, I got this value 1.05784, and we should give the value with answer with four significant figures 1, 2, 3, 4 over here. So now look at this, the number after the 7. Yes, that is greater than 5. Therefore, I should add another add plus 1 to the number 7. So the answer should be 1.058 milliliters. Right. You will see this grams to grams cancel out, and the answer will be must be given in the uh, milliliters. Questions?
Yes, can you hear me?
Yes, I do.
So why was that one four significant figures, even though there's a value in there with less than that? Like the point or the 1 gram, wouldn't that only be one significant figure? And you said take the lowest?
Yeah, but here it says 1 gram. So when you check those the significant numbers, okay, when it says uh, 13, 50, something like that, then it'll it we consider it has infinite number of the significant figures.
Thank you.
You're welcome. Okay, right. If you don't have any more questions, I'll go to the next one. Here we talk about a multi-step question. It said something like you do actually in the lab, right? A flask weighing 50.2587 grams can hold 62.55 milliliters of liquid. If the flask is filled with water at room temperature, what is the total mass of the flask and water? The density of water at 25 degrees of Celsius is 0.997044 grams per milliliter. Right. So we cannot get rid of these numbers. Because the answer, the value is correct up to this decimal place. So right. So we have to calculate the mass of the flask after it was the total mass after the flask was filled with water. So I'll write the mass, the total mass should be equal to mass of the flask plus mass of the water. Right. So, what is the mass of the empty flask? Yes, it is given. Okay, it is straightforward. But how we can find the mass of the water? Okay, we are given the volume, and we are given the density of that liquid. So using those two parameters, we should find the mass of the water. Okay. So we should use that the any liquid, okay, the mass, the volume of the flask is 62.55. It cannot hold more than that. So we know the volume, but we do not know the correct mass. Okay, so they said this flask will be filled with water. So we should use the density of the water to calculate the mass, right? So D equals M over V, and we rearrange this one to solve for the M. M will be equal to D times V, right? So mass of the water will be equal to the, we'll take the density. Oops. We'll take the density. It is 0.9, 0.99744. Please keep, keep an eye on this. The units, grams per milliliters multiplied by the volume. Okay, fortunately in here the volume is also given in the milliliters. If not that the case, you should change that to the milliliters. So the volume was given of the for this flask as 62.55 milliliters. So milliliters to milliliters cancel out. We will get the answer in the grams. Okay. So I'll got the answer. Okay, as 60 to 2 point, okay, whatever, here is the 3651 grams, right? Okay, now I'll go, right, okay, this is a multiplication, right? How many significant figures should I have with this one? Yes, this one has four significant figures, right? Let me use a different color. Four significant figures. Um, Therefore, this is not the final answer. So I'll keep one more significant figure. This is an intermediate answer. So 1, 2, 3, 4, 5. I'll keep it to the number 5 here. So I'll keep it as, if you are not asking the questions, can you please mute your microphone? Thank you. The answer will be 62.365. I'll keep like that, okay? Uh, Grams, right? And then we'll calculate the mass of the total thing, right? So what is the mass of the flask? It is 50.25 uh, 87 grams. Oops, what's going on sometimes? Grams plus now 62.365 grams. So now we have an addition. In addition or subtraction, the significant rule will be changed. So we then should look at the least decimal place. Here the answer has given with the fourth decimal place. Therefore, the final answer should be also uh, given with the to the fourth decimal place. So when I add that, I'll get 112.628 grams. Okay, yeah. So keep that in mind, right? So like the look at these, or carefully look at those, the significant rules when you're doing these, the mathematical operations, right? You have any questions? Okay, so I will uh, take a break now, And let me see. I'm gonna stop the recording now. Yeah.